Right. Welcome everyone to the Edinburgh DevOps Meetup number 24. We'll just wait a few minutes just for people to join us, and then we'll get started with the presentation. This is obviously the first of these meetups that's happened in a while, and just in a few minutes I'll go over the details of sort of who I am and where the organisation came from for this, and the changes that have been made to it recently. So as mentioned, we'll just wait a few minutes for people to arrive, just because obviously with the GoToWebinar registration, it does sometimes take a while. So yeah, I'll just wait a few moments and then we'll get started. And as a so for those of us that are just joining, we'll be starting in a few minutes, and we're just waiting for people to join, just giving them an extra few minutes. While we're waiting, actually, we'll do a quick poll just to see if this is the first time you've actually been to the Edinburgh DevOps meetup, or if you're a previous member that's joined in. So just to give us a quick overview of new people joining the DevOps meetup and returning members as well. One thing we will be doing in the future is sending out a list of potential topics for future meetups. And we do have a potential one lined up for the next meetup, which should be in around a month or two. But obviously we will be going through more of these meetups, and we want to try and make this a regular occurrence. So any ideas that you've got of topics you would like to see are also welcome. And if you just post them in the meetup group itself, we can take those ideas and see if we can get some guest speakers along, or if we can provide some content now. So just give it another few seconds. So yeah, it looks like, I'll just close the book. So it looks like the vast majority of people are new to the Edinburgh DevOps meetup. So there's 62% this is the first time, and 38% this is they're returning. So it's good, quite a good mix there. And I'll just give this a minute or so. So what I'll do is I'll quickly get started. Just to introduce myself. So my name is John Walker, and tonight we'll be going through two presentations. They're split up into a quick presentation, a demo, and then some Q&A time after that. So first one we'll be having is on cloud costs and the DevOps shift, and then we'll be following that up with DevOps versus MLOps. So just to introduce myself. So my name's John Walker. I'm the professional services team lead at CirrusHQ, and we're an AWS partner. So we are part of the Amazon Partner Network, and we provide services to clients working on AWS. We're 100% AWS focused, but this DevOps meetup group, obviously with it being more of a wider DevOps focus, we will be providing content that's not just AWS focused, but is applicable across the DevOps landscape. I'm also the co-organizer of the AWS Edinburgh user group. So that's a specific AWS group, and we do usually monthly or 2 monthly meetings there as well. I'm also an APN ambassador, So that's the Amazon Partner Network, and part of my role there is to help people get onto AWS and help them figure out solutions and give back to the community, essentially, with like blog posts, webinars, etc. I hold a number of AWS certificates, so I've got 5 at the moment, and I'm currently studying for the machine learning speciality one as well. And generally, I'm a technology enthusiast, and I've put down my sort of Twitter handle and blog post. So I do tend to talk about technology a lot, because I love technology, so quite a bit about me. And our first speaker is going to be Hassan. So Hassan is from Infracost, and he's going to be covering cloud costs in the DevOps shift. And I'll hand over to Hassan just now. I'll just make you the percent.
Awesome, thank you. All right, let's get started. See if I can share my screen, and I'll jump in and I'll start talking. All right, I'm hoping everyone can see my screen. I'm going to assume yes. All right, so I'm Hassan. I'm one of the co-founders of Infracost. I won't talk about Infracost too much. I'll show you a live demo later. 2 things I'll say. One is shifting left. Let's just quickly define that for anyone who kind of is thinking like, what are we talking about? And shifting left essentially means taking something and doing it earlier in the development lifecycle, right? That's what we mean by that. Just doing it earlier in the process. And the second thing is cloud costs can be pretty dull and boring topic. Therefore, I will use a lot of memes. So hope that that works for everyone. All right, so I want to talk about how we got here. At the beginning, when kind of the cloud came to be, we saw a lot of advantages that it could bring. We saw the Animoto example, if people remember that, which was like incredible amount of scale in such an incredible short period of time. And then once that scale goes away, scaling back down, the agility that you could achieve and how quickly you can get servers up and running and start being used. So at the beginning, we were like, this is incredible. Let's use more and more of this. And so we did. And what happened was we started using this stuff and actually putting production workloads onto the public cloud. And when you do that, obviously you get much bigger scale. And the other thing we did was a lot of lift and shift, which we said, oh, we don't need our data center anymore. Let's just shut it down and move everything over. And so what naturally happened next was the bills arrived. And the bills at the beginning, we were talking about, you know, in the 2010 to 2014, 15, bill shock was a real thing. Like you would get a bill and you're like, whoa, where did this even come from? How did we spend this much money? So we got a shock and we asked the cloud providers, hey, can you help? Like, what's going on? And they're like, easy. Here's a 1 gigabyte CSV of your bill that shows you exactly what you've used. Enjoy. And I don't know if anyone's tried to open up one of those cloud billing CSVs on their laptop. Their laptop will probably kill them. And if it doesn't, the contents will. The contents are incredibly detailed, incredibly large, and incredibly hard to kind of do anything with. We went from loving the cloud, getting cloud bill shock, and the solutions we come up with was taking these CSVs and building products on top so we could show back to users how their costs are trending. They can slice it and dice it and see what resources they're using, where the money is actually going. I'm not hating on these tools. What I'm showing you right now is RightScale Cloud Analytics, which is I was a lead product manager for between 2012 and 2016. So we let you understand what is actually going on. Okay, So what happened? Well, we got a lot of visibility, but the visibility was post-deploy. Something had to go to production. It had to incur charges. Those charges need to come through to the bill or the CSV. That CSV needed to be processed, and then you got visibility. So it was pretty further along from the kind of post-deployment. The second part of it is we give visibility of what's going on to managers and finance. We give them visibility, obviously, but we didn't give them context of what this stuff is, and that caused some troubles. And I'll talk a little bit about that in 2 seconds. However, if you've lived through this, you know where the work comes back to. If you want to shut down a server, if you want to migrate something, if you want to right size it, whatever you want to do, the work still comes back to DevOps people to actually action it, right? So we would get situations, and I remember these, where we said, kind of managers would find a cluster of servers and they say, oh, look, the CPU utilization on these things is super low. We're not using them. Let's shut them down. And our DevOps team would be like, yes, do you really want us to shut down our hot disaster recovery system? Like, it's meant to be up. It's meant to be at 0% usage. In fact, if we get usage, that's a bad thing, and it's still running. Or the other part was, oh, we got together with finance and we bought a bunch of reserved instances, and here's the instance types that we bought reserved instances for. It's like, wait, hold on. We're migrating away. We're going to use managed K8. We're going to use, different services, different servers. So without that context, with it being very late, and then all the way coming back to the DevOps action, we still had a lot of waste in the cloud. So that's what happened. Now let's look at why that happened. If we really look at the details of what went on, you kind of instill it down to these things. One is the feedback cycle was way too long. The things going into production, things coming into the bill, getting analyzed, then feedback happening of like, oh, this thing that we shipped, 2 weeks ago, 4 weeks ago, 2 months ago, this is expensive, let's change it. So that cycle between going into production and the actual feedback coming back was way too long. The second thing is it didn't come back at the right time, it didn't come back in the right place either. And the way I kind of talk to people about this is, if you think of the sprint as a 2-week sprint, what happens is you work for 2 weeks, then something goes to production, and you move on to the next sprint. When the developers and DevOps have moved on to the next sprint, the charges are incurring, and then the bill comes. So the bill is out of sync with the developers. They're already busy. So if you want them to do more work, it's like, hey, go talk to the product manager and get sprint time. Like, I can't just drop the current sprint and work on this other thing. And the other thing was, we built a lot of dashboards and we built a lot of tools around, but we never really deeply thought about what is the process that a user has to go through to get this information. So it was outside the pull request, it was outside the development review, it was all outside of that. And then finally, the thing that still surprises to people when I kind of talk to them and they haven't been involved in this is, in cloud computing, the people who buy products are never shown the price. This blows people's minds still. But people will buy resources and they will never be told how much this thing costs. That is basically like saying, okay, I'm going to give you access to Amazon and I'm going to remove all prices. Choose what you want and don't worry about it. I'll just charge your credit card. And so one of these things might cost £450 and the other one will be £20, but you have no idea. And this is incredible, as we still live in this place where developers don't see how much stuff costs. And then on top of that, there's 3 other complexities. The first one is the infrastructure code. So We don't have to click on buttons to get infrastructure anymore. We're basically writing code. And when we're writing code, we write code next to application code as well as infrastructure code. And what that looks like is you might write a bunch of code that will have no impact on cloud costs. And you might write one line of code that might actually blow the budget up completely. That's enabled now. 2 is self-service. We want people to launch resources whenever they need it because it makes sense. I'm not saying we shouldn't do it, because the advantage of cloud is to have people move fast, and when they need resources from the cloud, do it. Just launch resources and let's go. But the third one is a super interesting one, which is in 2012, when we were tracking this stuff, and we were building our first startup and company, we were tracking about 10,000 price points. Currently in our database right now, we have over 3 million price points. It's impossible for anyone to know what is ultimately going to have a cost and what is not going to have a cost. It's super hard. So let's see where we go from here. There's 2 things I want to talk about. One is the most simplest formula that you need to think about this, which is price multiplied by quantity is the cost. And it's super helpful to think of it this way, where you've got how much this resource costs, how much of this resource do you need, and that's how much your bill is going to be. Now, a lot of companies start to work and play with the first part of this equation, which is the price. And what I mean by that is you buy reserved instances. You go to Microsoft and you get EA discounts, enterprise agreement discounts. You get custom negotiated rates. Those are all playing with the price, not the quantity. And it makes sense because the price is usually a lot easier because you just talk to someone and you get a discount. And the other part, the second part of this is called the Prius effect. I don't know if people have heard of the Prius effect, but the Prius effect is in the Prius cars, there was a pretty dashboard in the car where it showed how well you were driving. If you brake the car, put your foot on the brake, it will charge the battery. And then if you suddenly put the gas on, it'll burn through gas and it'll tell you, hey, you're doing good or you're not doing that well of driving. And researchers found that purely by showing the driver how they're driving made them better drivers. They're more economical drivers because they weren't burning petrol. So our point is help the people who are buying the resources. Show them how their code changes are going to affect these cloud costs. So now I can talk about InfraCost. So it's InfraCost.io, and essentially what we do is try to sit in the workflow and show the DevOps and the SREs and developers how much these things cost before they go live. So it's either InfraCost.io, or if you go to GitHub and search for InfraCost, you'll see it. So now I'm going to attempt to do a live demo. Let's see if this works. Okay, so InfraCost is a CLI tool. You can download it. It's just run brew install InfraCost and InfraCost register. And basically, you say InfraCost breakdown and point it to a Terraform file. You don't need cloud credentials. Terraform might need credentials, but we don't need it. You don't need agents. You don't need anything. So what we do is scan down the Terraform file. We pick out the different components that have a cost. And this is the hardest part of building this product, which is what actually does impact the cost and what doesn't. Then we create this super simple output, which says, oh, okay, this thing is going to cost you this much, this $740. And then there's something else, which is these cloud is usually 2 parts, right? There's the usage-based resources and non-usage-based resources. You pay for them regardless of what it is. So we have this thing called a usage file. So you can model how much you're going to need this thing. And it's not going to do it's not going to run anything, but you can do what-if analysis this way. how many monthly requests you think you might get, and how long those durations are, or how many gigabytes of S3 you have, things like that. And then if I point it to the usage file and rerun it, what we can see, hopefully, there we go, is the Lambda function is also using these quantities to calculate the cost. So you can see the cost has gone from $740 to about $1,200. So that's InfraCost's CLI. Think of it as an individual contributor. You can just download this on your laptop, you can run it, and off you go. But I like, my favorite part of this demo is actually if I show you, by the way, you can, this is the repo, feel free to create issues and things like that in here. Let me have a look for this one. So this is the really cool part. You can integrate this InfraCost into your CI/CD, and if someone submits a pull request and says, okay, I want to increase the storage size in IOPS, without doing anything else, our GitHub Actions jumps in and says, okay, we've analyzed your code, and your monthly your monthly bill will go up by 37%. Now, because we can actually do a diff on this, right? We've got a pre and a post state. We've run InfraCost twice. We do a comparison, and we say these are the components that are going to increase your cost the most. So what's changed, what's been added, and what's been removed. And that right there is the most exciting thing. We've never shown developers this information so clearly to say, hey, here's how you can take action. If you need to, you bring the context and we'll just give you additive information to help. So that's all I had for my little demo of InfraCost as well. I'll stop sharing screen and John.
Yeah, thanks, Hassan. So we've got a few questions in. So first one really is on when you're doing the estimates, and obviously you don't really know the usage. How do you actually get an estimate of what the usage is going to be?
Yeah, great question. Okay, so think of the cloud as two different types of charges. One is static charges, which is regardless of if you use them or not, you will be charged for that price. So Redshift, instances, it doesn't matter if you use it or not, you're just going to be charged. And the second component is things like data transfer, S3. They're usage-based fully, in which they will only charge you for usage. What we do currently is InfraCost generates the output and says, here's what I can estimate because I know the usage, it's fixed costs. And the other component is I'm going to give you an output which you can model your usage what you have. In our GitHub repo, we're working on something that you could connect this to your cloud provider, and we could pull basic usage out from, let's say, Datadog or CloudWatch or something like that, and populate that usage-based resources as well. And that's to help you have context of like, oh, this instance is expensive relative to like our full other usage costs, which are like pennies or the other way around as well. So that's what we're working on as well.
So you could use things like if you've got an instance that only runs business hours during the day but is shut down at night, like a dev instance, for example, you can use that to then get the actual cost of it.
Bingo, yeah, exactly. So if you've got like development environments in which you run up and down, then you have number of hours, and we could pull that information in and show you that as well. Or auto-scaling groups, those would be super interesting, right? So auto-scaling is from, let's say, 1 to 100, but usually you're running about 25. So we could model that for you as well.
Yeah, excellent. So just the next question, just around your company, really, what sort of made you start InfraCost?
That's a good question. So January 2020, we started a company that would help people hire DevOps and SREs. And the way it would do that is spin up a whole environment, a whole stack, and then break something, and then ask the DevOps to jump in and kind of fix that problem. And then our question was, okay, if an interview runs 4 questions, how much is this interview going to cost us so we can do a pricing and that we can kind of have. So that's kind of where it came from. And then COVID hit, the hiring kind of died entirely, budgets were frozen, and that startup died immediately. But Alistair had open sourced the Infracost, the first version of Infracost, and then it really took off. A lot of feature requests, a lot of requests for additive resources, and then we go into Y Combinator, and then we've kept going, and it's growing since then.
Excellent. And just on another question here, just on the pricing model. So, are you able to model against things like spot instances?
Yes, yes, we've got spot instances in there, which are painful because of how much prices change, but they're there, and reserved instances as well. So you can do what if analysis. What if we buy these reserved instances or those reserved instances? You can use the usage file to do that what if analysis as well, and or usage patterns. So you could say, oh, okay, if this thing that we're shipping to production only gets used, our normal base amount versus 10x, what does that look like? So those are the kind of questions that managers would ask, and we help the DevOps get those answers for the managers. But mainly it's focused currently on getting the DevOps understanding of, oh, here's how these components are going to cost.
Okay, excellent.
Yeah.
And I think we actually have a sort of related question just on reserved instances and savings plans. Does your cost calculator have that in there, so that if you've got, say, an M5 large, but you've got a savings plan set up for that, is that something that would be able to bring into the calculation?
You can bring it into the calculation via the use. No, you can't. Not currently. Right. So what we're trying to do is design like the EA pricing and specific charges and things like that. But I think I've been pretty open about this. I think that will be in our paid plan. So currently, Infracost is fully open source and fully free. I think that's when we'll start charging, which you connect to your cloud provider and pull in your custom rates. Your everything that you've bought on top, basically. And that's probably how we'll fund it.
And one thing I was just wondering myself actually is when you've got that the cost estimate, are you able to get a breakdown of where that cost come from, like fully down to the actual like the individual charges? Because some of the cost calculations you end up with, there's a page of 3 or 4 different things that you need to add in. Does it break all that down? Yeah.
Yes, you can get right to the breakdown. And ultimately what we're trying to do is say what, and we can do a lot better here as well, but what line of code costs what? So that you can say, oh, this one thing was super expensive. Let me just, that line of code is the only one I need to change. So it really make it actionable for the DevOps, for the individual contributor to actually have that impact as well.
Okay. And just another, are you able to compare costs across regions?
You can, yes. So if you run it on the CLI, you can basically run a specific version and then change anything you want and do the what if analysis and run again. Then you've got two outputs. That's actually a lot of people talk about like multi-cloud, and they do it as a negotiation tactic you could do, which is like, oh, I'm going to compare AWS and Google and get the cost output and take that as an EA pricing discussion, which is a use case. You could do that as well.
Yeah, excellent. We also have another question in here. Can you use Infracost with Terra Grunt?
Yes. If you go to our docs, we've got a Terra Grunt kind of section as well, and how you can use it with Terra Grunt as well. And then if you use Terraform Cloud, we actually announced our partnership with HashiCorp a month ago. Armon announced it at HashiConf. So soon, the new Terraform Cloud run checks, you can basically plug in Infracost into run checks, and that's it. Every person who's running any changes, they will see what the impact of the costs are going to be as well.
Excellent. And is it just is Infracost just limited to Terraform?
Currently it is, yeah. Currently it is, but we need to build it out. So we need to build it out and have, I think, CloudFormation supported, Azure ARM I'm getting requests for, Pulumi. So a lot of these other IOC tools, we need to support those as well. And the way we're doing it just now is via the GitHub issues. Everyone puts a thumbs up. So the biggest requested is what we're going to kind of focus on. So if there's something specific that anyone wants, just put a thumbs up on that GitHub issue, and we'll definitely focus on that.
Excellent. That all sounds great. So don't believe we've got any more sort of questions at the moment. So what I'll do is I'll take over and start the second presentation.
Sounds great. Let's do it.
Okay. Okay. So as mentioned, the second presentation we're going to go into is DevOps versus MLOps. So the idea behind this presentation is just to give you an idea for those who are new to MLOps specifically, what the differences are when you're working through an MLOps pipeline and a workflow, and how that compares to existing DevOps practices. So just before we get into MLOps, one thing I want to do is just define what I mean by DevOps, because although this is the Edinburgh DevOps meetup, so a lot of people here will be familiar with DevOps, but it can mean different things to different people. So it's worth defining what I mean by it. And you've all seen this sort of workflow before, where the idea behind DevOps is to build in that sort of feedback loop and go through your processes and make sure sort of as much of it is automated as possible, and have your code, do the testing, do your releases, monitor your workflows, and have your metrics and have your feedback all flow through, so that each of your different teams or combined teams all have the right information that they need. So having your testing done up front, as Hassan mentioned about shift and left, and actually moving things that you would normally do later on in the process up to the front end. So looking at testing, looking at costs, actually having the people who are writing the code have access to the later steps as well, is what I kind of mean by DevOps. So if we're talking about shifting left in a normal release cycle in a DevOps, this is the sort of thing that you might actually have. So you'd have your planning and designing, then you're doing your development, you do your testing, releasing, and then monitoring. So this would be a sort of standard non-DevOps setup, where everybody's in their own team, they're all siloed, and the further you get down the line, you may run into issues. So like your dev team may have a release that they want to do, but then they can't find a slot in the release team's schedule, or QA is working on another feature that they need to go through. So if they'd been involved early on in the process, then some of that time would have been spent a lot more wisely. So, and you could have separate teams, end up with delays and a sort of lack of communication between different teams. So with the machine learning workflows and using the benefits of DevOps, they are very similar, and typical machine learning workflows without MLOps are very similar to what I've just shown there of the different silos. The main difference really is that there's a larger focus on the actual data that you need for your machine learning. So the standard sort of machine learning workflow is gathering in your data and analyzing it, preparing it for use in a machine learning workflow. So that's things like dropping columns, doing one-hot encoding, which is taking a particular column and turning it into a sort of category value, taking the data that you've got, then doing your training and your tuning on your actual machine learning models, and then deploying and managing it. So as you can see, it's very similar to the dev, test, and sort of release cycles without DevOps. And sometimes you get a similar split of the data part, maybe a data engineer's working on that, then the model tuning might be a data scientist, then you'll have a deployment engineer, software engineer to integrate the actual querying of the model to get real-time recommendations back, and then a DevOps engineer or a systems engineer to actually monitor it. And again, you can see exactly where the same issues would come up, where you have the data engineers maybe need to wait on a data scientist, or they need to wait for a release, etc. And combining a lot of these roles or moving some of the tasks left is where MLOps will come in. So just quickly to go over the roles. A data engineer is generally someone who deals with the actual data itself. So gathering the data, analysing it, cleaning the data, and preparing it for the machine learning. So this part of the machine learning process can take the longest. Usually a model and its accuracy is heavily dependent on the amount of data that you've got and the quality of it. So as an example, if you're doing a fraud detection machine learning model, if your model could be absolutely perfect, but your data may not have that many examples of actual fraudulent behavior. So you would end up with bias in the machine learning model of a bias towards non-fraud. So having that a good split of different types of data of the things that you're actually looking for, or generating those examples if you know what the data looks like, is key to getting the model accuracy up. And a data scientist is generally someone who actually builds the models themselves and actually does the model coding and the testing and tuning them. And then you have a deployment engineer who'll take those models and actually deploy them to an endpoint where they can then be queried. And at that point, you need someone who's a software engineer who can actually integrate with that endpoint. So it may be an API, and you can take the live data that you get. So if you've got a booking site, for example, where you want to figure out if someone in real time is committing fraud, you would submit your details to the endpoint and get a result back whether it's predicted to be fraud or not. So you need someone who can integrate that into your front end application or your back end. And then you have the operations engineers who will monitor the models themselves, whether that's for the actual performance and usage of it, and report any issues with it. So they may be collecting metrics or fixing the model if it goes down, looking at the APIs and fixing that, for example. So as I mentioned before, data in a machine learning workflow is really important. So when you're doing a normal software development life cycle, your data is important as well, but it's usually related to the types of data you've got and the formatting. So things like making sure that people can enter their address correctly or their credit card information is valid. So a lot of it is about being able to handle types of data that you get in. But in a machine learning model, you need a lot more data, and you need a better relationship with data essentially, because as I say, this is the part that can take the time. So generally when you're doing the actual machine learning training and tuning process, you'll split the data that you've got up into sort of three parts of the training, test, and validation data. So the training data that you pass in when you're doing your training consists of the data that you know the outcome of, so whether it is fraud or whether it's not fraud, that sort of thing. And testing is used during the training process to actually figure out how good the model's getting on. So in some machine learning training processes, you can use the test data to say, right, okay, we're going down the wrong route here of what we're looking at in terms of features and how they fit together. And you can use that as an internal feedback loop to improve the model further. And then the validation data is once you've trained the model, actually taking some examples that you've stripped out the prediction for, where you actually keep the prediction in there in this case, and you present that to the model, figure out what it comes back with, and look at your prediction versus the actual outcome. So it's real data that you know is fraud or not fraud, or whatever your outcome actually is, and you're using that to validate that the model is actually working okay, and then you build an accuracy score from there. And once you actually get into the MLOps, using live data for feedback loop. So if once you've actually got it deployed and you're monitoring your model in production, it's really useful to be able to take outcomes that you end up knowing the outcome for. So say, for example, if you had a customer and you predicted it wasn't fraud, but your customer service team eventually found out it was, they can then feed that back to say the model predicted it incorrectly. You can then use that in your new training set as an example to reinforce the accuracy of your model. And in some cases where you're doing unsupervised learning, this is where rather than having a known outcome, such as fraud or not fraud, you're giving the machine learning model data and trying to figure out what the relationships are. So whether you have one feature that's heavily correlated with another feature, the more data that you've got there, the more relationships you'll find there, and the better you'll understand the actual data that you're getting in. And as I mentioned, we have positive and negative examples. So the more examples that you can give the machine learning model of areas where you know the outcome in a positive direction, such as it is or it isn't fraud, or in a negative direction where it is fraud. So that's something that you're looking for. The more examples that you've got of each class of outcome, the better your model will perform. So to be able to do MLOps, which is, as I mentioned, very similar to DevOps, and it's got some of the same goals, with the process for MLOps, what you want to try and do is automate some of the machine learning workflow in a similar manner to DevOps. So, for example, in the data sections, you might want to automate the actual ingestion of data. So that might come from live examples. You might have a feed from your website, or you may gather feedback from customers and then bring that in. So you want to be able to like upload that data and have it processed all the way through to the point where it can be used by the model. You may have automated model deployment into dev and stage, so that you can, with your data scientists, when they're actually tuning the model, or if they've got a new example that they want to try out, a new or a different algorithm to work with, then you don't need to wait for that to be deployed into your dev and staging environment for training. So if you've got your code and you submit it, you want that to be able to be live on your dev and stage, so that you can actually then go and test it and see what the accuracy is. The difference here with the MLOps versus DevOps is you don't necessarily want that to actually go all the way through to live, because you don't know what the accuracy is going to be, and you want to be able to experiment and actually have it on an environment where you can train it and figure out, is this better than what we had before? So you can do things like with machine learning pipelines, you can have a gate after the staging process, so that once you've actually got all of the all of the data and all of the model in place, then you run your test, figure out if it's better, and then only then, if you know if it's actually more accurate or is able to do what you want better, then you release it into production. And usually that life cycle process of the iteration of improving the model, improving the data, and then going back to your code and then redoing it again, that's where your iteration loop is, rather than the full cycle of releasing a new feature and then coming back and releasing a feature or releasing improvements on it. So you don't want to necessarily go through to production every time. And there are tools in the pipeline automation. So as with DevOps, you can go through your automation in different layers. So you can automate just to dev, or you can automate fully to prod. And there are things you can do with machine learning as well, with tracking the features that you're using in each model. So you can experiment with different features that you're going to be tracking. You can actually track your data as well. So if your data is changing in some way, and you can actually see those patterns to say, okay, we're training on, initially we trained on a set of data that didn't have a lot of examples for the negative class, but over time we've added more, and you want to be able to see what that split was. So you can go through the data tracking. You can also have a model registry, which is where you actually submit the model to registry, and it will record the model used, the accuracy, and the output of it. Excuse me. You can also use, as I mentioned before, use feedback loops. So this is where you monitor your metrics in live. Excuse me, sorry, frog in my throat. And take what you're finding in live and actually feed that back into your machine learning workflow, and use that to improve your models with live data based on what you've previously deployed. And excuse me, as I mentioned, with the machine learning workflow, you want to iterate more on the sort of data and model side of things. So the more experimentation you can do on the actual data or the model, the better your models are going to get. So you don't want to have to wait all the way to the end of actually having deployed the model before you get that feedback of how good this model is it better than our previous models? Is there anything else we can do to improve that? And within that process, when you've actually done the validation, it's good to be able to feedback right all the way to the start and say, okay, here's a model, it was 93% accurate. Feed that back and then look over the data, see if there's ways to improve it. Train a new model and say, okay, is this going to be 95% accurate, or is it going to be less? And then try and figure out why that is. So not going through the full pipeline of deploying to production, but allowing your data scientists and your data engineers to iterate on what they have. So in terms of MLOps itself, there's various different areas where you can automate things. So as I mentioned, you can go to the full extreme of having everything automated end to end, but generally what I would say is sort of start with the processes that you're repeating all the time. So things like taking in the data, analyzing it, preparing it, and potentially the feature engineering where you're deciding which of the columns of the data that you're training on are actually useful for you. So as an example, we having a look at customer churn, where customers have like a mobile plan, and things like their name isn't going to be relevant, so you would drop that. The phone number itself isn't probably going to be relevant, but like how much they're paying each month, how much data they're getting, how much they're using, all of that data is going to be useful. So choosing which features to use greatly affects the model you're going to get out of the end of it. Then you have the model training and experimentation as well. So actually using that data to then run it through a model and changing the model parameter, the hyperparameters for the model, and figuring out where you can tweak things to make the outcome better. Then once you've got that model there and it's running, you want to analyze it and figure out, is it better or is it worse? And then once you've actually done that and you've got a good model, you want to deploy it. So automation of the deployment process into, as I mentioned, into dev and stage first and then into production is really useful. And once it's actually live, you want to do performance analysis on it to make sure that what you have actually deployed is useful. And with DevOps as well, you can do similar CI/CD pipelines to DevOps in the MLOps world, where you can hook up to things like GitHub and code commit and actually deploy your model code all the way through, or you could use it for deploying your data to the instances for training. And you can also provide feedback loops with the data as well. So now that we've covered the different areas that you might want to automate, these are some of the tools that you might use. There's a really useful MLOps tools GitHub page that goes through all the different variations of all these different areas and the different tools that you can use for each one. So you've got this DVC, for example, is a version control platform for machine learning. It's based on Git, but it's focused more on machine learning. You can use MLflow as well, so that's Apache MLflow. That's a full platform for the full end-to-end machine learning lifecycle. There's ModelDB, which is where you would have your model registry, using the versions, getting the metadata out of your models and doing experiments. And yes, Flight as well, which is a Kubernetes workflow automation process, so similar to MLflow, does the full end-to-end process. And the last one I want to mention here is this, the LFAI Foundation. This is a page that details a lot of the different areas where you can, or the different tools that you can use. It's not comprehensive. There's some things in there that are maybe categorized away, but are actually useful for each individual one. But I'm not going to go through the whole thing, but I just want to give you a glimpse of the different amounts that there are there. So as you can see, there's hundreds of different things you can use for each one. So in each of the different areas like programming, deep learning, this webpage does have a lot of different areas that you can work through of, okay, which tools should I use for this area, and what are the different options that I have. It does cover the majority of the big ones, but as I say, there are some missing there as well. So, and that's my presentation. So what I'm going to do now is just go through a quick demo just of SageMaker pipelines, essentially. So this example is going to actually be based on AWS. So that's where my specialities are. So the idea here is to show you a machine learning workflow on AWS, but a lot of the ideas of how it works are very similar. So if we have a look in here, this is our SageMaker Studio. So this is a tool that Amazon have for, it's essentially running a Jupyter notebook, but it's got a lot of different features in there for the full end-to-end pipeline. So you can run the different notebooks for machine learning. You can go into the console, you've got a terminal built in. But a lot of what I'm going to show just now is the sort of projects and SageMaker pipelines of deploying the models that you've got in here. So if we have a look at this project here, this project contains two repositories. One of them is for building and training the model, and the other one is for deploying. And what that has done is it's actually created two pipelines in this case, but if we have a look into this particular one, this uses what's called a directed acyclic graph to go through the process of training and validating a model based on the code that you write to serve. This one's actually based on a template that AWS provides, so it's based on identifying abalone fish to see how many rings they're going to have based on all the different characteristics they've got. So it's a prediction model based on a number of features of the different crustaceans, I think there. And just to show you what where that comes from. So the pipeline itself, there's the code here about actually running the pipeline and interfacing with SageMaker is all pre-set up. And to deploy your own code to it, there's three sections that you need to set up. So there's a pre-processing step, which is where you're actually modifying your data. So that's your data preparation step. And this example, as I say, this is all from the Amazon template, and this is based on it's Python code based on using I think it's the XGBoost algorithm it uses. So essentially, I'm not going to go through the whole part of this, but the idea is that you want to get your data in, transform it, figure out what your different features are, and essentially write that out to a CSV file. So this whole file here runs in the pre-processing step. So if we go back to, so this is a pre-process abalone data. So once that's done and you've got your validation, then the main one for the training is going to be this pipeline Python file. So this is where you're bringing in a lot of different frameworks from SageMaker, but they're usual open source ones. So you've got like scikit-learn, you've got XGBoost in here, and there's some code in here about getting the pipeline. But the main one to sort of look in here is actually getting the processor and essentially splitting out the data that you've got into training, validation, and testing. and then running that through the framework. So in this case, the framework in SageMaker is going to be using is XGBoost, which is a prediction one, and then you actually run the training. And this will run on a machine learning optimized instance at this point, and then it will actually give you the output from that, and then you run the training data and the validation data against it. So there's a few more steps about actually uploading the output of that, figuring out what the metrics are, registering the model to a model registry to mention you can track which different versions you're using. And then this last step here was where you have an evaluation step, so that if your model is less accurate than you want it to be, so in this case we have it's a value of 6, so you can do things like if we've got an 80% accuracy or more, then we're fine to go to the next step, otherwise reject that model. And that way you're not wasting time deploying a model that's not very good. And then once you've actually got that, I'll go to the next step in the pipeline. So you've done the training, then we'll go through the evaluation step, and that's where the evaluate code comes in. And again, this is just based on the same data that you passed in, so it's the validation and testing part that you've got. And what you do is you take those values and predict versus what the value actually is. So you do the prediction here, figure out what the error rates are, and pass that back into SageMaker. And then once you've evaluated it, this step here will run through whether your new model is accurate enough to go to the next step. And if it is, it will be registered, and that part of the process will have been completed. Now, once you've got the model deployed, and it's registered, it'll be registered in this in the SageMaker model registry. And at this is an example I approved yesterday, which is now deployed into production. But initially, when it comes in here, it will be on the staging side of the pipeline. So you can see here it was originally in staging, and you can look at the metrics for each one. So in this one, you've got whatever your metrics you had in your pipeline and evaluation steps are registered in the model registry. So in this case, we're looking at the mean square error. But if we look at another one I did previously, the metrics are on accuracy and area under the curve. So whatever metrics you define can be put into the registry itself. And once you've got a model into staging, with it you can say whether it's been approved or rejected based on the accuracy. And then when you update that status, this particular pipeline actually has an event bridge in the background that's looking for this change of state. And once it's actually marked as approved, then it'll go through another deployment of the pipeline and deploy that model to an endpoint. So if I just have a look in SageMaker, so just to show you the actual endpoint. So in this case, the one endpoint that I've left up is this Abalone production, and it will show you the different metrics for the invocation of it, show the instance type, and which model has actually been deployed in there. So that endpoint is now live for predictions to be done against. And with SageMaker, because it can run Jupyter notebooks, this example here I've got is where I've run a prediction against the endpoint that has been deployed based on some examples that I've got here. So I'm passing in the parameters, and this was my expected value of 10. And when I did the prediction, it came out with 10.6. So it's reasonably accurate to what we were actually looking at. So, and yeah, so that's the demo. So what I had wanted to do is have a look at changing the model and deploying it and showing the full process through. But with the deployment process and the training and the amount of data, it does take quite a while. It can end up taking 20 minutes to go all the way through. So this will show you the full process. But obviously this is an AWS specific name. This is showing you SageMaker pipelines, but a lot of the same concepts are available in other platforms. So for MLflow, for example, it has a model registry. It can deploy endpoints. It can do all the same sort of processes. So this is Amazon's specific way of doing things. Okay, so I will stop sharing my screen just now, and we'll just see if we have any questions or anything just now. So yeah, if there's any questions on any of the Amazon process of deploying models or detailing with the data, then yeah, please feel free to ask them. So the question to you, just where in the pipeline would GitHub come into play? So in fact, if I just quickly reshare my screen just now, so in this example, this is actually using code commit, so it's using Amazon's version, but each one of the repositories here with the pipeline in it and the actual the model code, that's linked up to a code commit repository. So have a look in here. See, I've changed this the project. But this is all of the code that we've been writing in terms of the model code and the data that's coming in. All of that goes into a code commit repository. And then in this case, we have a code pipeline. So if we have a look at, wait a second. Yeah, so we have this model build pipeline, which is looking at the code commit, commits into the main branch, and then it builds it using code build and deploys that model into the next step, which then executes the pipeline. So yeah, it's completely linked up in terms of automation. So you have the code commit, which will then run the full pipeline. So when I was training this and did these runs yesterday, each one of these in the project, each one of the pipelines is showing the executions. So that execution was triggered by the pipeline that was then triggered by code commit. So you can use that automation all the way through. Okay. So yeah, just wait a few moments and see if there's any further questions. But yeah, if there's any further questions on any of this talk or on Hassan's talk, then as I mentioned, feel free to enter them into the meetup chat, either for this particular one or for any sort of other one. So I just did that. So another question, and then in terms of the notebooks that are run here on SageMaker Studio, what sort of languages can you use? So you can use various different languages. You can actually create a notebook and then decide which kernel type you've got. So you can use basic Python, you can use R, you can use a few different things, but the different kernels within the notebooks are based on just the standard Jupyter notebooks. And you can also have specific ones that Amazon have defined that work better with their GPU instances. So Amazon have a lot of machine learning EC2 instance types, and depending on how your particular code is working and which frameworks you're using, some of them might be better than others. So choosing a different type of optimized notebook can actually change what your outcome is as well. So just another quick question in terms of if we can give a quick example of a feature in ML. So the one example I've got here in terms of this data set it's an example of customer churn. So the data here was manipulated to figure out which of these is actually going to affect the output of churn. So in each of the data we have things like, it's a US data example, we have the US state, the account length, like how long they've actually been there, area code, phone number, where they've got different plans, etc. And each of those different elements of the data are what your features end up being. So the idea with a lot of the training is you want to find out which pieces of the data that you're looking at relate to each other, and if there's a strong correlation there, or what you might find, for example, is you might find customers are churning because your charges in the evening are quite high. So people on different plans, the people who have a lower charge in the evenings are staying with you longer than the ones that are getting higher charges in the evening, even where everything else is roughly the same. So like the length of service, etc. So that's where you're deciding which parts of the data to use in your model, and that's where a lot of the feature engineering comes in, and a lot of the data acquisition and cleanup comes in, is getting that right data and choosing the areas that you want to focus on and how they relate to each other, and whether you want to maybe combine ones as well, is a lot of the data analysis process, and where a lot of the time and machine learning is taken up. Okay, so I think we'll sort of stop it there just now. As I mentioned, we'll have an announcement on the meetup group of the next upcoming talk, which should be in a month or two. And obviously we've been doing this one virtually as well, but over the sort of course of the next few months, and once we start getting into next year, we will be looking into bringing back the in-person events as well. And we are potentially looking at a sort of hybrid event where we'll have an in-person event and speakers, but we'll maybe stream it to a site as well, so something like Twitch or YouTube, so that people who can't attend in person are still able to actually see the talks and sort of ask questions, etc. as well. So if you have any other ideas of areas you want to have a look at, or DevOps questions that you have that we might be able to answer with either myself coming along or a guest speaker, then feel free to message anywhere in the user group as well. And yeah, I just want to thank everyone for coming along. I hope you enjoyed both of those talks, and thanks very much to Hassan for his cost talk, and thanks again everyone. We'll leave it there. Thank you.